Hi, my name is Yonis, and today I want to talk about how solar panels work in terms of how it converts its solar energy into electricity. Why do we care? Well, in 2017, it was recorded by NASA to be the second hottest year since 2014. In fact, data shows from 1880 till 2017, the average global temperature has increased. And the reason for this is due to fossil fuel emissions such as CO2 when we're driving is contributing to this. And in terms of the effects environmentally, frequently more hurricanes are occurring. As well, sea level has been rising. Now back to solar panels. To have a good understanding of how solar panels work, which contain solar cells or photovoltaic cells, we have to go back in time to 1905, where the famous physicist who came up with the equation E is equal to mc squared, otherwise Albert Einstein, realized that light was not in waveform, but in actuality was in discrete particle form, also called photon. And when that light hit a metal surface, for instance, depending on the frequency, the electrons in that metal surface would escape. And so the formula which relates to this is E, which is energy, is equal to H, which is Planck's constant, and V, which is frequency. And this is also known as the photoelectric effect. And now to semiconductors. Solar cells, which consist of the chemical element silicon, which is a semiconductor. Now, semiconductors have properties of a metal and a non-metal. Now, for example, silver, which is a metal, has a structure where the individual atoms have weakly bonded valence electrons, providing electron movement and electricity. On the other hand, oxygen, which is a non-metal, has 6 valence electrons, and in these valence electrons they are very tightly bonded, disallowing any sort of electricity or electron flow. Now silicon, or otherwise semiconductors, consist of pure silicon atoms connected to each other through covalent bonds. Now there's different ways of looking at also semiconductors. You can look at it as band structure. Now metals have a band structure where the valence electrons, where the electrons stay and have conductance bands. Electrons jump from the valence to electrons, but here there's no gap, as we can see. Semiconductor has a band gap in between them. Now that we understand how semiconductors work, we can now discuss how electricity is actually created in solar cells, which is also called the photovoltaic effect. Now, in regular semiconductors, silicon is pure, but when you want to create a photovoltaic effect, you must dope it. In this case, we see that phosphorus is added into the silicon configuration, and that allows an extra electron because phosphorus has 5 electrons, and electron has free-flowing movement, which is called n-type. Now, p-type basically is doped with boron, which has 1 less electron than silicon, and that creates a hole which is positively charged. But also, this positive charged hole is allowed to move around. Now, when you add both of these n-type and p-type, you get a p-n junction. Now, what happens is with the p-n junction, you have holes on one side and electrons on one side, and the electrons want to migrate to the holes because they're positively charged, creating a neutralization. Now, when light is in the presence of this p-n junction, the photons excite the electrons from the hole, and the holes go on one side, which is positively charged, and the electrons go on the other side, which is negatively charged. Now, this negative and positive charged sides creates a current. When you put an element in between, it'll create a current,